Hello again to everyone. Welcome to the MicroStream EclipseStore Advanced training. For those of you who didn't heard about that, MicroStream and EclipseStore are start with a warm-up as promised. So we do a small project from scratch. So I prepared a small micronaut project, and you will be able to import that. I will share the GitHub repository with you, and there are some few classes in it, and you have time, I would say 20 minutes to do your own coding on that. And then after that, we try to do it together. And this is just to summarize everything from the fundamentals training. And then we move on to the configuration advanced. I would like to share some specific or some special ways to initialize MicroStream or EclipseStore. Sometimes it's quite important to know how does it work, how to initialize the storage, and so on. There are some differences, and I want to share this with you. Then we talk about storing advanced. Storing advanced means we talk about eager and lazy storing. What are the differences between eager and lazy? What about transactions and how to roll back stuff? This is also important. And I would say one of the most important topics, especially for today, is lazy loading. Because as you all know, MicroStream EclipseStore, it's an in-memory database, but there are a lot of questions regarding, okay, what happens when we have, or when I have 2 terabytes of data, and how to handle that within in-memory. And this is how we can handle it. Then I want to share the lazy collections also with you. Since version 8, we added the lazy collections, and I want to talk with you. There are not finally because there are in the collections are available, and you are able to choose them, but we are still working. We are still improving the collections itself, especially the performance on that collections. But for the moment, they are working great, and yeah, let's talk about that later on. And last but not least, I want to talk about legacy type mapping. This is also a huge question, so that is asked all the time. What happens when my class is changing? And let's clarify this. And I'm pretty sure there are a lot of more questions and side topics, I would say, depending or regarding to your questions you have. And this is also an important thing from my side. Ask as many questions as you can. Whenever you want, just type it to the chat. I will do my best to add some breaks where I can answer that questions, and then I think we will be able, or I am able to answer everything you want to know. Just a small links, but no worries. I will share these links later or again. These are the basic documentation of MicroStream. There is another documentation also available on the EclipseStore page. Then we have our GitHub repository, where you can find a lot of example projects regarding MicroStream. And there is also my GitHub. There are additional projects, and especially there are all the projects we do within the trainings are available within my GitHub. And no worries, as I said, I will share the links with you at the beginning of each section of the training, I would say. Regarding certificates, just a second, I have to let some people into the training. They're joining late. Okay. At the end of the training, I will share a link with you. This is kind of like a Google form, and just type in the small informations we ask, and then you are registered for the certificate, and also to share the video and the recorded stuff. Okay, so the guy who asked, if you have to leave, just raise your hands and ask the question. I can share you the link. Earlier then. Okay, so give me just a second, then I can just fix my monitor a little bit better. So, okay. Now I can see the chat. Okay. So let me just summarize MicroStream or EclipseStore a little bit, basically the theoretical part. So MicroStream, what is MicroStream? Basically, it's a Java framework. It's quite easy to say. What is MicroStream? It's a Java framework. And it consists of from scratch invented object graph serialization. That means we do not use the Java serialization itself. We invented our own way to serialize object, and this enables us to serialize every graph and every Java object, and update these serialized stuff partially. That means when the idea was born many years ago, we tried to serialize with JSON, for example, but the problem is whenever you serialize something with JSON, you have to update the whole JSON block again and again, and that's a big problem. And the difference to our serialization is we are able to update it partially in the end, and with that thing, MicroStream becomes more and more, I would say, a database. So that means we serialize the data to the most known systems or file system. We are able to serialize it to AWS S3, for example, to Kafka, to all relational databases, DynamoDB, Redis, and many more. And as I said, we are able to update the data on the storage side partially. We keep most of the data in memory. So that means if you leave it as it is, so if you use MicroStream or EclipseStore with no special things, then I would say all of the data stays within the memory. But yeah, we talk about that later on when we talk about the lazy parts of that. So that's why we say keep most of the data in memory. There is no data mapping anymore. That's also important. It's just the beans. So you just have to handle your own beans. And for example, you have your customer. You don't need any annotation and stuff like that. So you can use the beans as they are, and there is no data mapping needed anymore. Just pure POJOs, I would say. So let's have a short look. Yeah, in the end, it's just change the data in the RAM, and MicroStream takes care to keep RAM and storage synchronized. This is, I would say, this is a basic explanation how it works, and we will do some further explanations during the training, but this is the basic explanation of MicroStream itself. Okay. To any graph database, it depends a little bit. There is one question from Sashi, right? To any graph database like Neo4j, not really sure if you have a Neo4j connector, but you can have a short look to the documentation, and if there is Neo4j listed. Otherwise, just use the GitHub discussions to ask for Neo4j interface or stuff like that. Yeah, as long as there is the possibility to store a binary file, it should be possible to create an interface for a specific database.
Neo4j is not supported so far.
Okay, thank you. So, but anyway, just ask it on GitHub discussions, and maybe we can do that for you, or we can give you some support for creating an interface. Okay, let's move on to my warm-up exercise, and I prepared a small project. You can find it on that URL. Sorry. Yeah, let me just share the URL for you. Yeah, it's there. Oh, okay, that's the repository. And you will need an IDE, of course, of your choice, and no special IDE required. What you will find on the repository is a Micronaut application. And just check out this application. I've already done this exercise on the fundamentals training. Maybe some of you might remember of that project. But it's good for a warm-up, so that's great. So give me just a second. So here we are. Is it necessary to increase the resolution, or is it okay for you? I think the most important thing is the code itself, so I can increase the letters, so you will be able to see what's going on in my IDE. But especially for the left side here, that's the car controller car exercise. That's the project itself, and it consists of a few classes. The important thing is you should use the start exercise here. So just check it out. Switch to the branch start exercise here. And then there are some classes which are already prepared to work in. And just let me just switch back to the presentation. Where is it? Oh, I closed it. So just a second. Okay, so as I said, check out the car exercise. I posted the description, and start at the branch, start exercise here. And then you just have to complete the following classes. The first class is the DB class. This class is for initializing MicroStream or EclipseStore. And then there are two controller classes, so which contains the interfaces. The rest interfaces are placed within the controller classes, and all the other classes are already there. So let's just jump back to the ID. So as I said, the DB class is the empty one, and then we have the two bean classes, brand and car, which are already implemented, and car. And there is one class which is called company, and we use the company as the root element, or the root entity. And this company contains the name of the company and two lists of brands and cars. And you can keep this as it is. And then in additionally, we have the two controllers. I already talked about that. There is one, it's the brand controller, which returns or which has one interface who is returning the brands, and one to insert a brand. And there is another one, which is the car controller, to list the cars, to find or to find some cars by model and by brand. And there are another two. One is to delete cars and to insert. And as I said, please use the builder pattern to initialize the storage manager. The channel count should be 2, and the store target is just data. It's just a folder which is called data. This is for you to know, okay, where to store that. But I would say that's up to you where to store the data itself. And I would say, if there are no questions so far, I will give you, let's say 20 minutes to try to implement the most important parts of the project itself. Only these three classes are important. And if you want to see the whole project, you feel free to switch to I think there is one branch which is called implementation done, I guess. Let me just double check. Car exercise team switch to. Okay, there is just a master branch. Yeah, the master branch is the branch where everything is already implemented. So that might help you to, if you're stuck at some points, you can have a short look to that branch, and then you will see how it is solved. So okay, let's say 20 minutes for you. Just check out the project and try to initialize the classes and the storage manager, and try to do some implementation stuff on the interfaces here, on the REST interfaces. Looks like the app will allow inserting of a brandless car. Yeah, that might be the case. I think it's just a short example to cover all the main important parts, so storing things and so on. That is, it might be possible that the business logic is not, it does not cover everything. So yeah, it's just to know the basic CRUD functionality, how to initialize MicroStream or an EclipseStore, and yeah, it's just about that. So one thing which is also important, you to get this application running, so you have to enable the annotation processing feature of Maven within your IDE to let it run. So within Eclipse, it is working on window preferences, and then just search for annotation processing. It's below the Maven section, and then you will find the annotation processing, and then you have to select experimental or the automatically configured. Both will work, but that's important. It's also to enable this. And after that, you will be able to switch to the application class itself and right-click on it and say run as Java application. And this is how it basically works. Then you will see all the stuff, the initialization stuff of MicroStream, and that's it. Thank you. So so again, so I shared the link with you, especially for the Visual Studio Code annotation processing stuff. Just have a short look to that. And yeah, MicroStream supports, of course, Java 17, but it's an old project, I would say. So hello again to all that joins later. We're currently doing a small warm-up exercise. Let me just share the link to the project again. So this is the project we are currently working on. So if you want, just check it out to any IDE of your choice and try to implement the 3 classes DB and the 2 controller classes. So let me just share the exercise description with you again. Should be helpful. That's not the right. Okay, this is the description of the exercise. That might be helpful. For those of you who joined the advanced training directly, so I think it's a good moment for you to have a short look to the documentation, especially the getting started section. I think there is a lot of good stuff within that documentation, especially how to initialize the storage manager. Let me just, so especially this section could be quite helpful to initialize a storage manager. So as I said, use the builder pattern to, in my opinion, it's the easiest way to initialize, but sometimes there are some needs to use the foundation method. I will also share this with you later on, but I think that's the most straightforward way to initialize. So the getting started. So I can share the link with you. This is the getting started section. Within that section, I would say the create database. This part could be quite interesting for you. This, I would say, this is the most lightweight version to initialize the storage manager. Just say embed storage.start, and then you have to hand over the root object, and the path where to store the data. And in that specific case, we store the data directly to the hard disk. Yeah, and as I said, there are many different ways to do that. And this is the way we want to talk about within that exercise. So, or this is the way we used it in that exercise. Okay, it's 5:50. I would say let's start together to give you a small explanation or summarize that a little bit from the fundamentals training. The first thing we have to check the dependencies we need, and especially in that case or in that project, I saw that we have two different versions. We should correct this. Let's change to the latest one. I will also change this within the repo at the end, but we want to use the version 8.1.1. I think that's, or I'm pretty sure that's the latest version. And most of the time, or for the easiest example, we just need the embedded storage dependency. But if you want to do some further configurations, we need this dependency additionally. So as I said, we need these two dependencies that are already in place, but you should update this to version 8.1.1, which is the latest one. Okay, so let's start on the DB class. And the first thing we need is the storage manager. And just a second, okay, so let's start. So we need public, static, and then it is called embedded storage manager. This is the database. I would say this is the database manager or the database management system itself. So whenever you want to access to the database itself or to your objects, you have to call the embedded storage manager, and let's call it storage manager. So that's okay. So we need a storage manager. And by the way, this is one way to initialize the embedded storage manager. There are many or thousands different ways to initialize it. Maybe via dependency injection and stuff like that within Spring application and so on. It's totally up to you. I prefer this way. Keep it clean and simple and use a DB class and then use it in a static way, but it's totally up to you. Important is you need one embedded storage manager within your application. There is the possibility to have more than one. You could have multiple embedded storage managers. Each storage manager represents one instance of a specific database. So, and in that case, we need one storage manager here, and then we need one root object. That's important. We always need one root object as an entrance object to our object graph. And in our case, it's the company object. So that means we say static final. The storage manager could also be a final. Then we say static and company, of course. Company, let's call it root and say, okay, it's new company. Okay, here we are. So that means we need these two objects are the most important objects for MicroStream or for the storage itself. The storage manager as the database management system, I would say, and the root object as entrance object to the graph. So then we say we create a static block in that case, and let's initialize the storage manager here. So let's say storage manager equals, and then we could call embedded storage configuration. Let's call the builder pattern, and then this enables us to do some configuration. And I want to start with the channel. So let's say channel count 2. What does it mean, channel counts? I already explained that in the fundamental training. The channel count is the amount of, I would say, threads to access the hard disk. And this is also the amount of folders which are created on startup. So that means for each channel, there is one folder which contains the data. And in that specific case, we use channel count 2. That means at the end, we have 2 folders on the hard disk, and we access the hard disk, or we write down data and we read data from hard disk in 2 threads, I would say, internally. That increases the performance, but you have to keep in mind if the amount of the amount of channels are too large, then your data will be segmented, and you need a lot of time to collect all the data from the different channels, and that could lead to a decreasing performance. So you should have something in between 1 and 4 channel. That's for most cases this is totally okay. Most of the time, I personally use 2 channels. That's totally okay, or that's okay for me. Okay, then we have to set the storage directory. In that special case, we say, okay, just store it in a folder which is called data. And this is what I've already done few hours ago. And you can see the data folder up in the upper left corner here. In my case, there is one folder which is called data. I already created this folder, and here you can see the 2 channels, and there is the persistent type dictionary. So I will come to that later. Storage directory, then we want to create the embedded storage foundation. This is what you always have to call because we need the foundation object, which contains most of the configurations. And based on that foundation, we create the manager. So we'll create embedded storage manager, and there is the possibility to add the root object directly in that embedded storage manager object. There should also be a possibility to set the root object, maybe on the foundation, I guess, from set root. Yeah, you see, there is the method set root. So that could also be a possibility to say set root, and then we don't have to do it here. Different possibilities, but I would say in that specific case, we add the root, we hand over the root object to the storage manager in that way. And last but not least, we have to call the start method. That's really important to start the storage and to initialize the database itself. So in that specific case, when we access the DB class the first time, the database will be initialized. And this is exactly what we want. And whenever we access it, there is one object and one instance of the embedded storage manager that returns the data for us. That's all we have to do here in that class. We need the 2 objects, important objects for MicroStream, and then we have the configuration part here within a builder pattern. I think that's a really solid configuration and should fit for most of you, especially when you start to use MicroStream. Okay, so let's have a short look to our root object, just to clarify that. The company is the entrance object to our object graph, and the company as a root object can consist of most of the Java structures or Java collections. So that means the company object contains all the lists and sub-objects of your object graph. And in that specific case, we have a string for the name and 2 lists for brands and cars. But these lists could also be hash maps and sets and so on. It's totally up to you to create your graph like you want and you need it, which fits best to your application itself. And I think that differs MicroStream a little bit from Hibernate. You don't have to build an object graph which fits best to Hibernate and your database. Within MicroStream, it's important to create an object graph which fits best to your application needs. And I think that's one of the biggest difference between an object graph for Hibernate and an object graph for MicroStream. But yeah, later on, I will explain you a lot more regarding the data structure. Okay, let's jump into the beans itself, to the POJOs itself. There is a brand POJO, really straightforward, no annotation needed. And we have the car itself, which contains a model and a brand, really straightforward, nothing special. Keep it simple in that specific case. And yeah, let's start with the brand controller, I would say. There is one method which returns the whole brands. And let me just also switch to the brand controller. Okay, the implementation of the brand controller is really straightforward. So when we want to return all the brands of our data of our database, then we just use the DB reference because it's a static one. So let's call DB dot. So let's get the root object. So this is, as I said, it's the entrance to our object graph. Just remember, this is the company object in the end. Then we can say dot get brands, and that's it. So this is, let's imagine we call the get brands method at first. Then the database will be initialized because we access the root object and we access the DB class, and then just we return. And at this point, when we initialize the database, the database knows where the data are stored and what path. In our specific case, it's a data folder, and it loads the data automatically from the hard disk. So okay, that's it. So that returns the whole brands, what we need. Let's move on. Insert a brand. Or let me just switch to the car controller because we have the same method inside the car controller to return the list of cars. And in this case, it's the same. Let's call db.root.get cars. That's it. Let's stay on that car controller class. This is also a question which is asked a lot: how to get data out from, or how to query data within MicroStream. And the answer is all the time, just use the Java Streams API. You have to imagine the data are within the RAM, and just use the Streams API. So in that specific case, when we want to find a specific car by its model, we would start with a stream. So that means, let me just call db.root.get cars, and then I say stream.filter. Let's say C for car dot get model dot equals ignore case model. I think that's okay for now. And then we have to say cars by model. Okay, collectors dot to list. Just do this. Collectors. Here we are. So now that should work. And then we could say to list. That's it. So let me format that a little bit. So let's say stream filter collect. Yeah, I think that should do the trick. So this enables us to get the data straight from the collection itself. And this is how to find data within a MicroStream. So whenever we want to access the data, to query data, we use the Streams API. And it's the same by brand. So I would say just copy this one, and let's say c.getBrand. And in that specific case, it's a string. So we need to access the brand itself. So let's say c.brand get name dot, and then we say equals ignores case brand. I think that's it. And this should do the trick. And this is also the way how to access data, to query data. And this is, by the way, also an answer. Many people ask, just a second. I forgot what I want to say. Okay. So they ask for is the data structure within Hibernate, for example, or is it the same? So, and this is a little bit related to the company object here, for example. In that specific case, it contains two lists. One list are the cars, and one is the brands. And this is very, very similar to a normal database, right? So you have your database, and there is one table with brands and one table with cars, and there are some primary keys and foreign keys within thing. And this is really similar, but in this could look different if you want. So, for example, maybe we do not need a list of brands. So because the brand could be one field of the cars itself, right? So when we have a look to the car entity, as you can see here, there is already a brand within the car. So that means there is no need having a list of brands within the root object. But in some specific cases, you will need the brand within the company, because it could be the case that you want to show all the brands within a combo box, for example, or stuff like that. Then you will need a list of brands. There is a second example for let's say you delete the last car, or you sell the last car from a specific brand. Then you will lose that brand within a list, right? So when you have a car here, or a list of cars, and you will be able to, you could query through the cars and say, okay, let's give me the brands. But if you sell the last car, you will lose that brand, and this makes it necessary to have an additional list of brands within your storage. Some of you might say, okay, that duplicates the data. This is not the case, because the brand here and the brand within the cars are the same reference. So they reference to one specific object within the storage. And you could have as many brands as you want in different lists, and this does not doubles your storage. So, but sometimes it's helpful to have an additional list of brands here, and that's why it is in that case. Okay, so let's move back to the car controller. By model, by brand, clear cars. That could also be interesting, how to delete data within MicroStream. It's also quite easy. Let's db.root.getCars.clear. So this is the first step we have to do. Let's do it like this. Okay, that clears the list of cars. And then we have to store this. This is the first action where we have to store data. And there is this is the first time we need to access the storage manager. Let's say storage manager dot store. And this point is really important for you, because this is one of the biggest mistakes, or the most made mistake, I would say, within MicroStream. People do not know which object has to be stored, and in that specific case, we use we call it the lazy storer. So when you say .store, you will get a lazy storer. We talk about that, what that means later on, but you always have to store the object which has changed. So, and in that specific case, of course, there are a lot of cars are deleted, but the really object which has changed is the collection itself. So because you cleared the collection, so that means the collection is empty now, all the references are removed, and that's why you have to store db.root.getCars. So this is basically how it works. So you always have to change the object which has changed, or in other words, the reference holder has to be changed or has to be stored. So I think that's, oh, let me just return. Okay. Just a second, choose the right one. Okay. I will copy paste that. Return HTTP response. Okay, cars cleared successfully. Okay, let's move on to the last, I would say, CRUD functionality, the inserts. And here in that specific case, I added some additional business logic, and that's why I just I will copy paste that. It makes things a little bit easier. Okay, let's have a short look to that. In this case, I hand over a car object as a data transfer object. It's because to keep it simple. In I know that it is much more better to have own or specific data transfer objects, but in that case, it makes things easier to have the car itself as a transfer object. And based on that car, I do a first call to find if the brand is already in place. So give me just 1 second, I can share this with you. Car exercise. Insert car. Yeah. Here you can see this is the postman, and this is the call insert car. And in that specific case, we have that JSON object, which is handover. And there is one brand, which is called BMW, for example. It's part of the JSON file. And when we now have a look here, so I first stream through the brands. and try to find the right brand, or try to find if there is a brand still available, which is called BMW. And if this is the case, this optional here should be present. And if it's present, I choose this brand, and I create a new car object, set the brand, set the model, which comes from the data transfer object. And then in that specific case, I think it's the same, db.root get cars.add the car. So I have to add the car to the collection. And then in that case, the collection is the entity which has changed. And this is also the reason why I have to store the collection, because I have added, or I added a car, and this is why I have to store the collection itself, because the collection has changed. If there is, let's say we loaded that car, for example, and I say car set brand, if I update something, then I have to store the car itself. But yeah, let's talk about this later on a little bit more in detail. I think that's quite clear what's inside that class. Let's jump back to the brand controller. There is another which is really similar. Just to complete this example. In that case, it's the same. There is the check if the brand is already in the database. And I check if the optional brand is present. And if not, then I create a new brand. I set the name. I add the brand to the database or to the collection. And then I have to store the collection itself. So db root get brands. Otherwise, it's not allowed. And if the brand is a new one, then I return HTTP response. Okay. And that's it. That's the whole example project. And I think that covers a little bit the CRUD functionality, the basic function of how MicroStream or EclipseStore basically works. There are many more details, but let's talk about that details later. Let me just, before I answer your question, let me just start that project. And for that, let me just revert all the changes I made. So, this one. So we do not longer need this. Replace. And yeah, let me push the version changes directly. Upgrade to latest MS version. So here we are. Okay, so let's move to the next branch, to the car exercise branch. Switch to the master branch, which is already implemented. And give me just a second to change the version also here. Okay, so 8.1, 8.1. That's it. Okay, so you have seen that I've deleted the data folder here. And yeah, let's try to start the application. So let's move to the application class. Let's say right click. Let's do a Maven update first. Maven update. Just to ensure everything is built, and then say run as Java application. Okay, you see now the server is up and running, and we are able to reach it with the localhost 8070. So let's open a new browser, or we can also use the Postman. So we have that within the Postman. And so let's call all cars. That could be interesting because database is empty. Let's try it out. 8070 cars. That's sent. And as I said, on the first access to the DB class, MicroStream will be initialized with the version 8.1.1. And you see the result is empty. So let's move on to, or let's insert some brands. 8070 brands insert. Then let's start with Audi. That's it. That's at BMW. Let's use Toyota. And let's try to get a list of brands, all brands. 70. Here they are. These are the brands I have entered. And let's have a short look here to the data folder, which is automatically created again. So let me just refresh the project. Here it is. You can see the data folder. And as I said, there are two channel files. Just let me summarize that a little bit. There is one file which is called persistence type dictionary. I already explained that in the fundamentals training. The type dictionary contains all the Java types within the database itself, because you have to imagine how MicroStream works behind the scenes. There is each object which is stored within MicroStream consists of one object ID and one object type ID. And then the data comes within a binary format. But and to identify each object within the storage, we need the type ID and the object ID. And the persistence type dictionary contains all the type IDs and the description of an object itself to identify the object within the storage. So this is a really, really important file within the storage itself. And the two channel files here contains the data itself. So the binary format, it's not a readable format. It's a totally binary format, but it's not readable. And there are some additional transaction files down here. Yeah, which is not that important, but it's used by the database itself in the background. But these files are not accessible in especially for you. So okay, the way how it is stored, that might also be important for you. MicroStream works in a way that no matter what you're doing within the storage, whenever you call the store method, the thing, let's say you update a car, for example, then this updated car will be attached or appended to the storage at the end. That means if you call the update method 5 times, then you will have 5 copies of that car appended to the storage. And there is one housekeeping process in the background. It runs from time to time, I would say, and it clears the duplicate entries within your storage. That means every time you call a store because you changed an object or you updated or you inserted or something else, the data will be appended to the binary file. And then there are some duplicates in it, and then the housekeeping process cleans it up. This is how it basically works. So, okay, we have the data folder here. I already explained that. Let me just start the application again, because I added some brands, right? And let's stop the application and start it again. Let's see if it is stored or not. So where's the postman? Here, let's check if the brands are already there. You see, database is initialized in the background, and we see all the one. That's wrong. So okay. So I could add some more cars, but I think it's clear what I'm trying to say, or this is the summarization of the fundamentals training, just to warm up the topics a little bit. So there is one question I see. What about transaction concept? And what kind of consistency do we have? I would say transactions are directly handled within Java methods. Everything you do within an event or is a single transaction. So you can cover this with the try catch. But yeah, as I said, I will come to that later on. There are some mechanisms to do rollbacks and stuff like that. But yeah, this is another topic for later. So, but every access to the storage is a single transaction. So that's a little bit up to you to design your transaction, and you handle that with try catch and stuff like that. It's pure Java, I would say. And there is another what consistency is. It is full consistency. So that means no eventual consistency within MicroStream. It's a little bit different on the cluster side, but on the framework side, when you use MicroStream or EclipseStore as a framework, which is already done here in that example, then MicroStream is fully consistent. Yeah, as Marcus it describes, each store method is an atomic all or nothing operation. So is that a joke, or 1.7 seconds for request with 3 small entities? Does it really fast? Let me just double check. Is okay. So I understand. The point is this was the first call, and the first call means the initialize. It's the first startup time. So yeah, that's right. So when we do it again and again, you see that there are 3 or 5 milliseconds to get the data. Something between 3 or 4 milliseconds. 1.7 was with the startup time. Okay. Some more questions so far. So let me just double check. I think it's time for the break. Not exactly sure, but yeah, let's do some 1 or 2 questions if there are some, and then I would say let's do the first break. Then we start with the lazy loading stuff after the break, and we add the different configurations and so on at the end of the training. But I really want to start with an important one with the lazy loading research topic, and I think that's the most important topic for today. So let's do that directly after the break.
Christian,
yeah.
I would love to take the chance and invite our audience to the EclipseStore Summit. So through JCon in 2 weeks, JCon World Online is in 2 weeks. We will have the EclipseStore Summit on Thursday. So because of there is no vendor day, so we decided let's do an EclipseStore Summit. So this day will be, of course, all about EclipseStore. We will have introduction sessions and deep dive sessions, and we will also introduce on what we are working on and what's coming next. So there is really incredible stuff in the pipeline, and we will introduce it. So our CTO Florian will introduce it, and also Christian, who is, by the way, our cluster team lead. So a lot of great stuff, and we will invite you. So ticket is for free of charge, and it's a ticket for the whole JCon. So this is a super great Java community event. So it's the only Java community conference globally. So more than people from more than 30 countries joining. Last year we had more than 1,600 participants. So take the chance, enroll, and we see us online at JCon. Just choose the JCon full conference ticket, and then please use the ticket code, and then you can book the ticket for free of charge.
Thank you, Marcus. Great. Okay, so no further questions so far. So then let's move on to the lazy loading part. In my opinion, one of the, so except the basics, of course, but one of the most important advanced topic, I would say, because people always ask how to handle terabytes of data, 5, 10, and more terabytes of data, how to handle this. And one solution, I really especially say one solution could be lazy loading. There are many more, of course, but one and a specific one, especially within MicroStream or EclipseStore, is the lazy loading functionality. And what does it mean to load data lazily? So let's talk about the topics for that sessions. So the first question is, why do we need to store and load data in a lazy way? We should clarify that. What data should be stored and loaded lazily, how to use lazy references, and some best practice examples. And I would say this is the important part, because you will be able to handle or to use lazy loading stuff in different structures or data, in different data structures, and also the question how to release already or lazy data if they are no longer needed. So let's move on. There is one project. I will share this with you later when we do the research. But let's start and let's have a look to why lazy references are important. Basically, as you already know, MicroStream is an in-memory database framework. So that means all of the data is basically, all of the data are in memory. And this is also the reason why MicroStream is that fast and performant. That means best performance. You will get best performance if the data stays in the RAM. And this is also the point. You always have to think about, okay, what is my main data? Which data do we need in the RAM all the time? And which data can stay on the hard disk? But yeah, as we already know, but in some cases it's impossible to hold all the data. And of course, it's not necessary to hold all the data inside the RAM, especially, for example, binary data and stuff like that. Most of the time, the binary data like images and videos, whatever, should stay on the hard disk. And some archive data and stuff like that could stay on the hard disk. Short, we need a way to decide which data should not be loaded to the RAM on MicroStream DB startup. That's as I said, by default, the whole data will be loaded into the RAM. It looks like this. So let's say we have one root object and there are some sub objects below. And let's imagine let's say it's 1 million or 100 million objects. And we start up MicroStream, we will have the same amount of data within the RAM. And this is how it basically works. So at startup, all the data will be loaded from the hard disk or from the hard disk, and that's it. But when we add some lazy points, so especially as you can see here, so let's say in this case, this collection is a lazy collection, for example, or this one and this one, then the result at the end could look like this. So that means this object stays on the hard disk. There are only the references which are loaded, especially. So, and when we access this object, we have to call a get method, especially. So I will show you the code later on. But yeah, in the end, it looks like this. And this is how it works, basically. Not really complicated. But the important thing is what kind of data structure is the best choice to handle it in a lazy way. So the question is, so now, when should I use lazy loading? And the first rule I would say is always on binary data. So whenever you have, as I said, images and blobs and stuff like that, or videos or whatever, this data should be always loaded lazily. As I said, blobs document images. And it's the same on huge collections. So always on huge collections with less frequented data. That's important. So of course, let's say we have a huge collection and you decide to have this collection or to load this collection lazily. And at the end, you have 400 concurrent users. And especially these users are searching or querying through this collection. Then it makes no sense to load this collection lazily, because the data will stay in the RAM anyway, because it's loaded by the users. So it doesn't make sense to loading collections lazily if they are in use all the time. So, and yeah, as I said, the more concurrent user you have, the more data stays within the RAM. It's like the same on your application server at the moment, and it's the same with MicroStream. So that means always on huge collections with less frequented data, like logs or archive data or something like that. Sometimes on collections with a huge amount of sub-entities, that could make sense. I would say, especially when you, for example, let's say we have a customer entity, and a customer entity, this customer or each customer contains a list of orders, for example. And if we don't need that orders all the time, let's keep the orders or let's load the orders lazily. And then when you show all the customers, the order stays on the hard disk. That could make sense. But as I explained, it's the same. The more concurrent user you have, the more data you will have on your application server. And I would say use lazy loading whenever if performance isn't that important, I would say. And of course, if the amount of RAM is limited, that's also, it's totally up to you to use lazy loading at any time. This is a small example how we could handle binary data. The easiest way is, of course, on the line 4, I would say. It's lazy. There is every lazy reference is defined like this. So just type lazy. It's an object which comes from MicroStream, and then you have to add the data type. And in that specific case, it's the byte array is wrapped by the lazy element, and that means that this image stays on the hard disk as long as you access it. A more advanced way, and this makes more sense to me, especially when you want to query the data, or you want to have a specific byte array, a specific photo or stuff like that, then it makes sense to add a string as an identifier, I would say. And then you can use it in a hash map. But so the basic handling of lazy is to use the lazy data type as a wrapper and add the binary or string or list or set or whatever, and add it within the lazy wrapper. At the end, if you want to add or access that byte array, for example, you have to call image.get, and this will bring you the data from the hard disk. So at the moment you call the get method, MicroStream gets the data from the hard disk. Yeah, as I said, best practice using hash map instead of list, set, to search for it, and so on. I think that's really straightforward. So huge collections. This is also an example how it could work. And I think that's interesting because it shows the way how to initialize it. So whenever you want to initialize an array list or a lazy array list or lazy list of books, you can do it this way. So type lazy.reference, and then within the brackets, you could add the new instance of array list of type book. And that means the whole list is within your lazy reference or your lazy wrapper. The biggest problem with that solution is that whenever you touch or whenever you want to search through the books, for example, you have to load the whole list at once. So because of, do remember we use the Streams API, and whenever you want to search through the books, you have to load the whole list at once. So that's why it doesn't make sense to use it in this way, especially when you have a huge list of books or with millions and millions of books, for example. Then you should choose a different way to use lazy. But that's why this is best practice for most low and medium-sized collections. So whenever you say, okay, this is a collection which is not used all the time, and it's not that big, and then it makes sense to have that within a lazy reference like this. But there are a lot of better solutions to use this lazy wrapper. For example, this one. It's a hash map based on a string, and that string represents kind of like an index. That means, for example, in this case, we could have the first 3 letters of the ISBN, or let's say the first letter of the ISBN of a book. And then we have a lazy list of books, and all these books are starting with that specific letter or number. And therefore, we could use this string as an index. It could also be an author, for example. So when we have an author object as an identifier, and then we will find all the specific books for this author, and then the hash map works like an index of a database. So this is a quite good solution. And in most of the cases, this will help you a lot to handle your data within MicroStream or EclipseStore. And this is also one of the best examples that it's possible to have or to use hash maps and other collections within MicroStream instead of just using pure lists and sets and stuff like that. Yeah, it makes sense to use hash maps also. Definitely. So, and as I said, this is best practice for huge collections. There are one additional way to use it, but I come to that later. And as I said, it gives you the possibility to define an index for books, for example. And do you remember the thing what I explained at the beginning? It's possible to have multiple hash maps with different indexes, for example. So it could be one hash map with ISBN or the first letter of an ISBN and then a list of books. Then we could have another hash map with authors and maybe another one with the, let's say, first 3 letters of the title of a book, for example. And then we have the list. It depends on you what kind of index you want to define. And there is always the question, does that double the amount of data within the RAM? And that this is not the case, because all the books are references. Of course, you have to care by yourself to handle those references. That means when you, let's say, you sell the last book, then you have to remove the book from all of that maps, of course. But it's a quite good way to define a data structure which fits best to your application. So, and this enables you to define multiple indexes to find your book. Yeah, as I said, there are many different indexes possible. Yeah, interesting one. This is also interesting to know how to clear the lazy images. So from in the beginning, or the easiest way is we are always able to call lazy image, and that in this lazy image is the lazy object itself. We are able to call the clear method, and clear means, okay, it clears the data from the RAM. But yeah, you have to consider that the garbage collection, we need the garbage collection also to see the result that everything is cleared. But the clear removes the lazy references from the RAM. So this is one possibility to do that. A second one is, let me just check. Yes, it's the automatic one. There is a default lazy checker, which runs every 30 minutes. And it checks, or let's say it runs all the time, I would say. But after 30 minutes, if an object is untouched, it will be removed from the RAM automatically by MicroStream. Or if you come to a memory quota of 75%, then the clearance will be triggered, and then the lazy references will be cleared. Yeah, but as you can see here, you are able to define the duration of minutes. So it's totally up to you to set some clearance or to configure the clearance mechanism of the lazy stuff. Okay. Any questions to the theoretical part of lazy loading? So let me just switch to the project. What is medium size collection? That's a good question. What is medium size? I think it depends a little bit on how big are the entities within your collection. So how many fields does are within your objects, and it depends on how many rows you have. At the end, I would say, yeah, you have to try it out. What is medium size? So when you say, okay, it needs 3 seconds to load the data, then it's okay. It depends on the amount of RAM you have on your machines. So I would say that, yeah, to say what is medium is hard to explain, but I would say more than 1 million is not medium anymore. So, but yeah, it depends on the objects itself. There is one question: how would I implement searching by multiple attributes? For example, I want to search by ID and also by ISBN or name without loading all objects into memory. There are many different possibilities, I would say. The easiest one, let's create an index which consists of all the values we talked about here. So let's create an index which consists of an ID, the ISBN, the title, whatever. So could be one solution. How to define an index like this? Let's choose the easiest way, a string. Let's put everything together within one string, and let's make it comma separated or stuff like that. That could be one possibility. Another possibility is to create one, or to split up an object into one main object. Let's say customer main, and it contains the name, last name, whatever, the ID, for example, and there are some detailed data, which is the second object. So I think there are thousands of different possibilities how to define an index which fits best for your application. I think there is no, I would say, best practice for that. Just yeah, you have to find the right thing you want to do. It could change during runtime. Yes, it could change, but not at runtime. So you will be able to adjust this later. In some cases, you have to migrate data, of course, because you stored it in that way. And then maybe you have to recreate the indexes and stuff like that. That could be quite challenging in some parts, but yeah, it's the way how it works basically. Let's have a look and do some research just to show you how it works. So and to give you an idea how much memory do you need for how much data. So and therefore I created one MicroStream training lazy demo project. So and I want to start on the master branch. Okay, here we are. It's the master. Let me just share the repository with you. So yes. Just a second. Okay, that's the URL. Oh, I have to send it to all of you. Okay, here's the URL. That's the URL to that lazy demo. And what we do now is, or what we are going to do now is, there are several branches on that lazy demo, and we just move from one branch to another with different data structures. And let's have a look what happened on the RAM size. So, and therefore I started the visual VM, and I have to apologize for switching the windows that fast. Hopefully you can follow that, but I'm not able to bring everything at one screen. So yeah, so let's see. Okay, so let me just double check if everything is all right to start with the first example. Refresh. Storage is empty. So as you can see, there is no data folder at all. So let me just explain you the example a little bit. There is one person controller, and it contains 3 methods. One is to create the person, and if you what you can see here is there is one in stream which runs 200 times, and every time it loads mockup data from a file which is down here. So within that mockup folder, there is one persons file which contains 1,000 persons. So that means whenever we run the person controller create persons, it creates 200,000 persons when we click on create persons. Then there is another one to get these persons, and one to initialize MicroStream, just to do nothing but to initialize the storage itself. Okay, so let's move on. So let's start the application. Second, I have to say, where is it? Maven update. Okay. Now, if you want, you can do this also on your PC. Okay, you see, application is up and running. Let's connect to that application. Here we are. So let's enable monitoring. So now we see here, this is the RAM for the moment. So let's initialize the storage. So localhost 8080, I guess, and say, let me just double check the person controller, persons create. So, or let's say persons/init. That's the first. So you see the storage is initialized, and yeah, it's empty, so it doesn't need that much RAM. So, and now I call the persons create. So now it starts, and just remember there is 200,000 objects now, which will be stored to the storage itself. That's it. So so it's, as you can see here, I use the browser for that. Later on, I will use the Postman. It makes things a little bit easier, and we see how fast it is to create 200,000. Let me just switch to the Postman directly. That makes more sense. So MS training. So lazy exercise. So let's create persons again. So let's call it again. Request is running. You see the RAM on the other side here. Okay, it's done. Let's see. 30 seconds for 200,000 persons in total, or we created 400,000 in total. Let's trigger garbage collection, and then we see this is the real result in that specific case. That means 400,000 persons need at the moment 2 GB of RAM in that specific case. And let's have a look to the JSON objects. I mean, that's also important to know. There is, at the end of each row, there is a huge amount of text. You see that? There is a huge string at the end of each person. It differs a little bit, but I think that's important to know, because that's not a lightweight. I would say that's not a really lightweight person with just 4 or 5 fields, but there is one which is a big one. So, and therefore it needs a little bit more RAM. Okay, we don't need that anymore. Okay, here we are. So, okay, that's it. So, and I think every time when we start the storage, so we could do that. We don't need this anymore. So let's close this. As I already explained, when we start the application again, okay, application is up and running. And you remember when I first did just the init event, let's just initialize the application. Oh, I will do that. I don't have a postman thing. Let's say localhost 8080/persons, and then use the init. And when we now switch back to the monitoring, you see at the moment of initialization, the data is loaded from the hard disk directly, as explained. So whenever you start up the application, you see that the data is loaded from the hard disk, and yeah, it's in memory part, and it's same sized as before. Okay, the structure of my root object is just a list of persons. And there is the biggest problem on that is not that let's say this are our most important data and we want to search all the time through person, then we are totally fine to have it within the RAM. So that's okay. But what happened, and that's the point, whenever we create a new block of persons, so that means let's call the create method again. You can see the last one needs 13 seconds. Let's create the next one. Every block of 200,000 persons needs a little bit longer because, as I explained, the data has to be stored again and again. And the more the collection grows, the more it needs to store the data at the end. It doesn't store the whole collection again and again, but the references have to be stored again, and that's why the create needs more and more. I'm not sure if that is a real use case, but sometimes this is one disadvantage of having everything within one big huge collection. Let's call the list persons. That could also be interesting. find person by mail. We don't have this. Person ID. I get this one. You can see it's quite fast. It only returns the names or the last names of the persons, but I think we are totally fine with that. Yeah, you see that? I think that's really fast, returning 600,000 row of data. So we will try it out with some more advanced examples. Okay, so that's the normal behavior I already explained. Let's move on. And let's say, okay, let's change this to a lazy list of persons, because this is what we are talking about. So for that, I have to refresh and go on where it is. So I have to clear the data. So let me just delete the data folder, and let me switch the branch, and let's switch to change to lazy. Okay, this is what we have now. It's a second branch. Let's start this. Okay, so let me just all cars. We do not need that anymore. This is don't save it. Don't need this anymore. Person create. So let's create some. Okay, I see. Sorry for that. I have to start the application again. Just have to do a Maven update. Okay. Now, see that? Don't need that anymore. So monitoring, you have to see the RAM. The result should be the same, like in the example before. Whenever we call a create, the 200,000 persons will be created in a different way, of course. So please keep in mind, this is also the startup time of the database. It's the first request. Let's create another block of persons. Let's have a look to the monitoring. So, and you see it's there is no special thing in here. So that means it's the same size when we do garbage collection, like with no lazy loading. It's the same. And in that specific case, we didn't change the clearance of the lazy references, right? So of course we have lazy storage, but when we add the data stays, of course, in the RAM as long as the lazy clearance and the garbage collection is running. So so now we had to wait 30 minutes or to 75% of memory quota, but to improve that a little bit, we could add the lazy clear method, right? So let's use lazy clear. So that means we add the persons, and after we add it, we do a clearance of the lazy references, because we do not need them just for adding, but after that we do not need the persons anymore, and it should be cleared. So let's see if this is working as expected. So another question to you: what happens on data initialization? So how should do you remember in the last example when we call the init, all the data is loaded from the hard disk? In that specific example, what should happen now? We use the lazy. It should stay low, right? So because we do not want to load the data all the time, so it's a lazy collection. So when we now call Just a second. Where is the init? So let's call the init. So as you can see here, it's a little bit higher because the lazy reference itself, the lazy object itself, needs more RAM than normally. This is quite normal because yeah, as you know, that the lazy reference itself needs RAM, but it's okay. So it stays on 200 megabytes. So what happened when we add another 200? What happened then? Person create. Let's call it. Let's see what happened. And this is important. This is why I call it all the time research, because it's nice to see what happened when even if we have lazy loading, all the already existing. So remember, we created 400 in the first round, and now we create another 200. So we have now 600,000 persons, and the RAM goes up to 4 gigabytes. Let's do garbage collection. Then I think it's a little bit lower. And you see, this is what happened after the lazy clearance. See that? We called the first, we added another block of 200,000, and after that we directly call lazy clear, and this is where all the data is gone from the RAM. So now when let's try to get the person IDs. You see, we have to load the data from the hard disk now. 600,000. And here we are around, so the data must be. So, and after that, when we call it again, data should be in memory. You see that now we need 200 milliseconds to get the data. At first time, we have to load the data, but after that, it's available quite fast as long as the lazy clearance is running. So you see, this is one opportunity to handle data lazily. But yeah, to be honest, this is also, I would say, not the best practice way to do that. And this is why I said this is okay for low and medium-sized collections. It works great till a specific amount of rows, for example, or but as I also said, it depends on the objects, how big are the objects within the collections, and so on. It has advantages and disadvantages, I would say. So, but yeah, first step. Let's move on. Let's see what happened if we choose a different collections. So let's delete the data folder. We don't need this one anymore. This is also not needed anymore. Move on. Team switch to change to map. Okay, here is the next one. A more specific one. That means this is an example with an index which could be created. In that case, let me just double check. String lazy person. I always have to see what's going on in that product, especially in the controller itself, to explain that a little bit. Create. Okay. Store. Let's see what is inside the store method. Okay. No, this is the add person is the important one. Okay, so what you see here is, okay, there is persons put, and then okay, the last name, and then it adds a lazy reference. Let me just double check. Just a second, I have to see what's going on. We have map persons. Ah, okay, there is, okay, this is the wrong branch. And now I see, now I got it. So team switch to change to map multi-maps. No, it is the right one, but the implementation is not the right one, I see. Okay, it's not that important. I think we could skip this because I would say that this is quite really straightforward. I think the only thing what could be important here is when let's move back to the first branch. There is one thing I want to share with you. It's how to add an additional lazy reference check. So, and this is what we have here. So this is the second way to define how to stop now. So in this specific case, I changed the lazy reference manager and specific the lazy checker, and I changed it to 1 minute. So that means when we add some data, you will see that after 1 minute, the data is automatically removed from the RAM. So this is a second way. You will find that small code snippet also in the documentation and also in that project, of course. See, we cleared the database. Let me just double check if everything is all right. Okay, this is not here. Okay, so let's start. So we need that. So to see the RAM. Okay. And yeah, let's create some data. So sending the first request. Data is increasing, that's okay. As expected. Okay, and now we have to wait 1 minute, and after this 1 minute, the data should be gone. So let's wait just a little bit. During the time, I could answer some questions if there are some. No. Feel free to answer. Okay, we created it at 7:30, so, oh no, 30 and 15 seconds. So I see when I click on garbage collection, data is still there. But after the minute, we should see that the data is gone. And so see that after the minute, you see the data is untouched and it will be removed from the RAM. I think that's also important to know. There are two different strategies to clear the lazy references. One is to use to configure the lazy reference manager and to define what fits best to your needs within your project, that the data stays within the RAM. And the next one is another solution is this line of code to clear the specific line of, or to clear the persons directly after adding persons. Okay, let's move on to the next branch. Just to show you that it's an extended version of using maps. I already talked about that. Switch to multiple maps. This is also a quite interesting example. And in some project, we used it exactly this way. You see there are two persons classes in that specific case. There is one person object, which contains all the fields and so on. And there is a second one, which is called persons. And this persons object consists of two lazy lists of persons. And yeah, there could be some more maps, of course, with different indices and with different indexes. And you can see persons by last name, persons by mail. It's, yeah, I would say it's totally up to you to define an index which fits best to your application needs. And this is how it could basically work. So I would say this is really straightforward. And as I said, whenever you add a person, of course, you have to add it to both lists. And whenever you store something, you have always to store both lists. So I think that's a quite good example. There are some things to do when you use this, but basically this gives you an idea how it could work. But last but not least, there is one additional solution which works, in my opinion, best, and this is the next example. So let's move on to the last, or to the this one, is it? Let's have a look. The controller we need and the data root. This one. It's a map again, but in this specific case, we used an index string and a lazy single person. So that means, yeah, it's only one object in that lazy entity. And there are a lot of advantages within that solution, because when we add multiple persons, we don't have to load the whole map, or we just add the objects directly to the map, and we don't have to store the whole map again, or we have to load the data when we add the elements. And for each person we add, we create an index which consists of male, and just for this specific case, a random UUID string, just to keep it, just to keep the key unique. So that's the reason why I add this in this way. But this is working really great. So, and therefore I want to show you that. Let's say refresh. Okay, we don't have any data. Let's close this. And let's double check the person controller. Okay. Okay, just create some data first. Run as Java application. And let's create the first entries. See, MicroStream is started and initialized. We don't need that so far. Let's create some new one, some additional ones. Oh, maybe it's interesting to see how is the RAM if we add, or if we use a lazy reference on each object. So maybe this could be interesting for you. You see, now we have 400,000. There are not that big differences between the normal list of objects. So that's okay. So let's add some more. Now we have 600,000. Okay, data is there. So what we now do is we can now close the application and start it again. And this is interesting because when we now have a look to the RAM itself, when we initialize the database, So we should see, yeah, I would say nothing really special. So I would call the init here, because so we would just see the RAM that we need for the index. So this is the RAM we need for the index, for the key values. And that's it. Now let's try to find some. So I want to share the controller class with you. So I added a method which is called find a person by mail. So let's see if mail is one part of the index. When we now use it, find person by mail. This should be the right one. And in that special case, we search for yeah, you know, someone which is called Ivana, whatever. Let's call that. And you see how fast it is. So you will get the data within 50 milliseconds. Of course, the first one was longer because you have to load the lazy data from the hard disk. But I knew there is a guy named Koch, or I guess more than 600. This you know that this data always the same data. So we will get, for each name we will get around 600 results. So when we call for Koch, you see how fast it is to search it via the index. So that means we search through around 600,000 with an index if in a hash map. And you see the object itself. This is the object of the value of the hash map. And this is quite fast, and this works really quite good. And yeah, I think that's and this is why this solution. So when you want to have lazy data or huge data in your application, you should use it in this way. This is a great solution and works in most of the cases quite good to have it like this. Of course, there are a lot of other situations where other solutions makes more sense. It's totally up to you. I think the important part is to know that lazy exists and how to use it. But the data structure behind the scenes is totally up to your application, for your needs, whatever you want to do. But now I think you know how lazy basically works. Yeah. Any questions so far? I think that's the most important information about how lazy loading works. And what are your thoughts about that? Is it special? Is it fast? Is it complicated? What do you think? And yeah, especially as I said, it's one solution. Most of the people I've talked, and also in the project we are working with MicroStream, they started with yeah, let's say around 2 terabytes or 4 or 5 or even more terabytes of data. And they always ask, okay, how to handle that? And at the beginning I said, using lazy loading is only one possibility to decrease the to increase the performance, or to ensure that data stays on the hard disk. On the other hand, it's always important for you to double check if it's really necessary to have that much data within your database. I knew in the past it was quite common that okay, we have one database, or let's say we buy one good performance database like an Oracle or a SQL Server, whatever, and then we put all the data to that database because it's there. So, and yeah, everyone uses a database to handle the data. But nowadays, you should differ. You should say, this is data which is needed all the time. And then we have data which is not needed all the time. So we could put it on a S3 bucket, for example, because this is data which is archive data, whatever. So you should think about what is the main specific data, and then you should skip data automatically. So there are some mechanisms. This is also a point where a lot of people ask always, what about scaling data? So the point is that you should try to find a solution that data doesn't scale that much. So for example, there are a way to say, okay, let's keep the first 2 years of orders, for example, within my database. And whenever one order is older than 2 years, it will be automatically moved to a different storage for the archive data. So that means your production storage stays the same size and fits totally fine for everyone. And for a specific case to search within archive data, you use a different data storage, which doesn't need that, which is not that expensive, for example. So just to keep that. So, and that's why it's more than lazy loading. So you have to check your data. You have to see what is the main data on your application server, whatever, and then you will be fine with decreasing your amount of data, and that helps really a lot, especially when you thought about to change to a different data storage solution. So there are many different possibilities to handle data different than in the past. Okay. Okay, let me just double check the comments. Very fast. Okay, great. How is it handled when using multiple instances of an application? How does it get synchronized? That's an interesting question. So, and we did this all the time within the training. So we created a Micronaut application. So, and this is the first step to create, I would say it's funny, but it sounds a little bit funny, but to create your own database, because that application here is a data provider. So whenever we call a REST endpoint or whenever we call data, this Micronaut application delivers data to everyone. So it doesn't matter if an Android client requests the data or a Fat client application somewhere else requests the data. Our Micronaut application delivers the data to everyone. And this is how it should work. So I knew that in the past, a lot of people, you have one database and there are a lot of applications around the database, and all of that applications accesses to one database. This is made by everyone, I would say, but this is not best practice. So we always said create one application owner, so or one application server which provides the data to everyone. That makes so many that has so many advantages, in my opinion. You should do that, and this is what we have done. So create a Micronaut, a data provider, and provides the data to everyone. This is, I think that's the answer to that question, how to handle data with multiple instances of an application. And on top of that, I would say that the next question would be, okay, is it the way to replicate the data? Yes, it is. We provide a solution within our cluster solution, and therefore there is a cluster storage manager and so on. But that's not part of that training for today. If you are interested in, just send me an email or let's do a meeting, and then I can show you how it works or how the cluster works, basically. Does it answer the question? I would say it was always recommended to create a data provider. And maybe I can go further. So let's do not handle the whole data on one data storage. So why not to split up your database a little bit? Let's say, let's create good modules, I would say. There is one module which provides the person. There is another module which provides the orders, for example. And that's there. So then you have multiple Micronaut instances that provide different data. And this is also an advantage, because when, for example, when the order Micronaut server goes down, you will get the persons because it's not it depends not on the orders, you know. So as I said, many advantages. Okay, great. Audience, sorry for joining the session between that. Okay. Is there any form to fill in for the session certificate? Okay. Okay. Can you please share again the resource reference posted earlier in the resource reference? You mean the URL of the application? The resource reference, I guess. Yeah. Let me just share this again. GitHub. Yeah, of course. So this is the example of the lazy demo. There are, as I said, there are some branches or multiple branches with different solution. All of them are okay, I would say, but for different situations, I would say. Okay. If there are no questions so far, then I would move on to the next example. I want to step back a little bit. There is also all the time the question of how backupping data. What about creating a backup? We added 2 backup mechanisms. Let me just check if there are if there is a PowerPoint presentation in place. Storing data configuration. No, it is not. Yeah, but this is not a big problem. So let's jump directly into the project itself. Give me just a second to find the right project. Backup strategies. So this is the next project we want to talk about. So Christian, the best way to benefit from MicroStream is to design the proper strategy of our data graph. Yeah, that's right. So I think that's the most challenging part of MicroStream itself. There are some smaller ones, of course, but in the past, you have to create a data structure which fits best to Hibernate. And it was always the same. There is one, I would say, structure that fits best, and that's it. But with MicroStream, you can do even better data structures for your application, and they fit that great, and you will get that much more performance from your data. That's incredible with MicroStream. I think that's exactly the case. Okay, one example: backup strategies. There are 3 different, I guess 3 different branches. One is the master branch, one full backup, continuous backup, and a special one, which is created. I created that yesterday for you because a lot of people ask me for an example how to store the data to the hard disk or a persisted volume, for example, and to create a backup for an S3 AWS bucket. And this is an example, but let's jump in to the first backup strategy we implemented with MicroStream. The first one, we call it a continuous backup. That means MicroStream creates a mirror automatically on every store. So let me just show you that. Let's call refresh. And this is quite easy to use. So let's jump directly in the DB class, and here we are. This is moment, foundation storage. Okay. This is one way to initialize MicroStream, and it's a little bit different to what we see before. In that specific case, we create an XML file, and we have the definition or the properties within an XML file. This is also possible. And there is one property which is called backup directory. And whenever you create a backup directory like this, as I said, a mirror is automatically created on every store action. So let me just show you that. So let's start this directly. Sorry. First have to do a Maven update. Now we're ready to go. Yes. Or double check the books create. Let's do so. So localhost / books/create. Okay, this is working. Let's see. Here is the example. Let's say books. Here are the books which are created. And now the interesting part is what happened on the hard disk side. So let's say refresh. And you see the data folder here. And yeah, as we configured, just jump to the XML, we have 4 channels in that case. So we have 1, 2, 3, 4 channel files. So we are able to access the hard disk with 4 different threads. We have our persistent type dictionary, and this is the backup folder. And the backup folder could stay somewhere. It doesn't matter if it's part of the data itself or it is a second persistent volume, for example. It's totally up to you, the position. And you see the backup folder contains the same structure. And as I said, when you update this one, also the second one here, the mirror, I would say, will be updated. And on startup, MicroStream will double check if both storages are the same. And if there is something wrong, MicroStream will do a rollback to the last working version of the storage itself. But the question is always what could go wrong, basically. So most of the time it's more about, okay, we have a backup, but most of the time you will not need the backup itself. This is a really great solution. I would recommend to not enable the backup at the beginning or on, I would say, during the development, because you have always to ensure that both storages stays in sync. And especially when you are during the development, you will delete the data again and so on. And then, yeah, it makes sense to enable the backup as far as you start to go to production. That makes sense. Okay, this is the mirroring. There is one section within the documentation that explains the mirror much better than me, I would say. Here you can find everything about backupping. So sometimes it's quite hard to find, but let's see. Here we are, just for you. So this is the link to the configuration to the backup directly. And to the continuous to be, so this one is the continuous backup. Okay, some people ask, okay, to do a full backup, yeah, to create a full backup, for example, every night or something like that, just use how is it called? Just use a oh, come on. So I can do it with the CLI, for example, just to copy the files to another place. I can't remember the name for the job. What is the name? It's a job. A job is the last one, but the first one I miss. A cron job, for example. So to copy every night the files from to another storage. But you should not do this because you never know if MicroStream is storing in this exact moment the data to the storage itself. And therefore, it's important that you use the internal mechanism to do a full backup. So that means whenever you want to create a full backup, you should do this via the MicroStream API. So, and this is part of the second branch of the backup strategies. So let's move there. Switch to full backup done. Okay, just skip that. I click T, switch to full backup. Here we are. And you see, especially for that solution, I used the framework Quartz just to create a scheduler to do this every hour or every 12 hours or every day at 2 o'clock in the morning. That's totally up to you. And what happened within the task storage full backup is just this one line of code. So let's create, or let's move on to the storage manager. Let's say issue full backup. And then it's totally up to you to write the backup somewhere you want. So it's really easy. Okay, that's not really really interesting. It's just a mechanism to create a full backup, which is part of your transactions. So I think that's the important point on that. Okay, and the more extended. There is one question. Is performance decreased if mirroring is activated? That's a good question. I would say not really. But yeah, to be honest, so if you write down I think if you write the data directly to the hard disk, it should not. So it's that low. So, but it could be if you write the data, for an example, AWS, that could be. But yeah, I think the performance is that fast that you will not recognize that. So check it out. If there is any issues on the backup, we have to double check that. But yeah, this is not a really problem. So I used the continuous backup many times before, and there are no performance issues. So okay, as I said, a more advanced example is this one. Switch to. So this is interesting because many people ask us, okay, that sounds interesting to store the data directly to S3, to an AWS bucket, for example. And to be honest, it is great to use an AWS bucket as a database, I would say. And the first idea is always to store the data directly, to have the storage directly on AWS. And that's possible for sure. But why do you want to do that? So let's imagine you have everything in memory. Then to have the data on S3 increases the startup time, right? So because you have to load the data once to get it from the S3 bucket. But in the end, after that, all the data stays in memory, and you don't care about if the data comes from AWS S3 or from your persistent volume. That doesn't matter. But if you have lazy elements within your storage, then the behavior is different, because loading the data from S3 is, of course, much slower than loading the data from a persistent volume. Okay, so what could you do instead of that? I always recommend to say, okay, let's keep the data on a persistent volume or on your hard disk, and write just the backup, the mirror to AWS. And this is what happened here. And this is also a great example because I show you the way to initialize a MicroStream is a little bit different. And here you see, I would say, the most complicated way to initialize MicroStream, but it's okay, I would say. So the first two lines we have here. So I think this is already known. We have our embedded storage manager, we have a data root, and in that specific case, I created a bucket name, which is called MicroStream Training Backup Example. What you have to do is you have to create two different file systems. The first one is a Neo file system which is made for the to store the data on the hard disk. And when we have a look at here, we see there is a file provider, and the directory is defined here, and this is for the storage itself. So set configuration, and then we say, okay, storage configuration .builder set storage file provider. This is especially for the storage itself. And there is a second one which is called BlobStore file system, and the BlobStore file system is I hand over my S3 client, genau, yeah, and in that utils method, there are my AWS credentials, so the access key and the secret access key. And this is added here. So this is the point where I say, okay, let's create a backup setup. So please create the Miro on the AWS side. And let me just double check this if there are no credentials in it. So I have to, yeah. So as you can see here, oh, come on, that's, yeah. So this is the utils method. It could stay the same on your side. Just enter your access key and your secret access key here. And you just have to define your bucket name here. And this example will work for you. So the data will directly stored to that data folder here. And when you start it, you will see that the Miro is also created on the AWS side. And that works also quite good. So it's a great technique to handle your backups. Okay, any questions so far? This is backupping. Quite easy, really straightforward, nothing special. We have the full backup and we have the Miro. And I think it's totally enough, these two solutions. There might be another solution to have, yeah, so incremental backups, something like that. It's not available so far, but yeah, if some more people want to have it, maybe we are able to implement stuff like this. I think there is one on the con side regarding the full backups. You always have to take care about cleaning your backups, because when you do a full backup, you have to take care about to only keep the last 7 backups, for example, like this. This is what you have to care about that. But I think it's totally enough to create a proper backup for a database. And whenever something goes wrong, and the question is always what could go wrong. So of course, when your hard disk crashes or stuff like that, I think that's the worst case. Just copy the storage from your backup back to the new volume, and that's it. That's all you have to do. Okay, questions so far? Let me just double check if there are some unanswered questions. I've seen there are, hello, does the MicroStream technology require resources, CPU, GPU, TPU in order to be deployed on the operator system, or we can just run it on a GitHub repository? Oh, a moment, I have to read this again for better understanding. In order to be deployed in the operating system. Be deployed in the operating system, we can just run it on GitHub repository folder. Okay, no. So yeah, MicroStream needs its own machine. So you will need CPU, you will need RAM. So because yeah, it depends a little bit on the application itself, and it depends also on the architecture you want to deploy. But in the end, it's a Java framework, and it needs an underlying Java application, I would say. No matter if it is a Java UI, a Java Swing or Java FX UI application, and you have your own storage on every single device, or if it's a micronaut application as a data provider, or it's a Vardin application for something else. There are so many different possibilities, but in the end, MicroStream it's just a framework. You just have to use that framework within your application. And yeah, I would say every Java application needs its own resources, its CPU and RAM, and therefore, yeah, it's made for an application. I hope that answers that question a little bit. Oh, let's take, okay, we already got this. Yeah, okay. If you use another S3 provider like Hetzner or Strato, only credits are different. Yeah, that's true. So I think it depends a little bit on I'm not sure about that, but I've never tested this. I just have to double check, but maybe Frank Frank, did you tested this? Sorry for asking directly you. I think we already talked about Hetzner and Strato, and as far as I know, they use the same access mechanism for S3. It's kind of like an S3 technology, I would say. It doesn't work? Oh, sorry. Okay. So, but that's a good point, especially for Hetzner and Strato. So we have to check that. And this is exactly where the GitHub discussions come into play. Just type in your wishes and your wish lists. And this is also the reason why we open source MicroStream or EclipseStore. Just let me know if you are interested to create, let's say, an additional storage provider or something like that. And you can have support from our side. So to give you an idea how to implement that and what are the main classes for you, you will be able to do that. There is one question, is the backup cleanup settings feasible via configuration? No, the cleanup of the backups, especially the full backup cleanup, you have to do it by yourself. There is no mechanism to control how many backups should be covered and so on. It's totally up to you. You have to define that. And you have to delete the old ones. Okay, so let's move on. Last important topic I would say for today is what happened if my classes changes. That's always a huge question, how to handle that. And I'm pretty sure I created a presentation for that. Yeah, here we are. So we call it legacy type mapping. And let's jump directly in. The first, we have to clarify how MicroStream handles data type. What happened if we do some changes in the entities? What changes can be handled automatically? That's also interesting. And as always, there is one project which provides most of the functionality. Let me just share this with you. That's important. Legacy type mapping. Okay. So to all, here we are. So that's the project itself on GitHub. And yeah, let's move on within the presentation. How does MicroStream handles data types? That's interesting. So this is one specific, or this is one part, or this is how the persistence type dictionary looks like. And what you see here is these lines here, the 0000000 and then 66 at the end. This is the object type ID. That means there is one specific type, which is called customer. This is the full qualified class path of the customer. And the customer consists of a string. and an ID, last name, first name, male, and gender. This is what is part of the persistence type dictionary. And inside the storage, it looks like somehow this. Yeah, it's not that interesting how it looks like in detail, but yeah, the point is each entry in the storage has a type ID and an object ID. I already explained it at the beginning. Each type in the storage has its own type entry in the dictionary, of course. And if there is an existing block of binary data in the storage, e.g. type ID 66, but this type is missing in the dictionary, the storage will not start. This is interesting. In the past, there was one error within MicroStream where the persistence type dictionary crashes, and that I think that's the worst scenario. And then you will need some recovery tools to get the data out of the storage. But this is gone, I would say. And yeah, but important is take care about your persistence type dictionary file. That's really, really important file. And it contains all the data types of your storage itself. What data types are supported? That's also always an important question. There is one list of data types that can be handled by MicroStream, and there are some parts which are not able to store. In the past, for example, it's the not sure about it, but the UUID itself, it wasn't possible till version 7, I guess. But after version 7, it's also possible to create or to store a UUID. And it depends a little bit on how the type is created and what is inside the type, or some generics or stuff like that. By the way, you should not store any third-party types to MicroStream, because if there are, so because of, you see that it's always the full class path of the customer. So what happened if the third party changes, for example, the class path here because something, because some refactoring stuff or things like that, that could lead to a problem. In fact, so at the end, you can open the persistent type dictionary, change the path here, and everything works fine again. But yeah, this is only one example why it is dangerous to store third-party objects within MicroStream. Okay, but let's move on. Okay, this is what happened when we add something to a customer. So that means this is the old one. We have ID, last name, first name, male, and gender. And this is the new one. So that means there is an IP address we added. It's another string attribute we added. And after adding another one, a second or a new customer is born within the persistence type dictionary. And that means when we store new objects, they will be stored as the new object. That means all the new entries have the ID 67, but there are still objects within the storage with the type ID 66. And this is why it's kind of like a versioning. That means when you change something within your Java class, renaming, moving fields within the lines, changing data types and stuff like that, leads to a new object within the persistence type dictionary. And whenever you touch an old one, it will be automatically converted to the new one if possible. So, and I would say most of the changes could be handled automatically. So that means renaming and stuff like that. This is all covered by MicroStream internally and can be handled automatically. But there is a possibility to let you control how to do the refactoring. And of course, there are some situations. For example, let's say if a data type changes from string to integer, for example. Yeah, that's how should that work automatically? That is not possible, of course. And I would say I always ask the question, what would you do on a relational database? How could this work on a relational database? And it's always the same. I recommend to say, okay, let's create a new let's create a new field, which is of an integer field, and then you have to add some business logic somewhere on startup, for example, to convert the data from one field to another. And after that, you will be able to delete the old one. I think that's the specific case when there is something which cannot be handled automatically, but we will come to that later. But just to understand, it's a versioning. The old data stays the same as long as it is touched and stored again. It will automatically be converted to the new one. This is how it basically works. There is, I already talked about that, there is a heuristic in the background which detects what field has changed and so on. There is some guesses, I would say. For example, he recognizes the data type, the string name, and the position within the class. And based on that, MicroStream guesses what happens in the end. So that means there is a first name, and you see this is moved. So he says, okay, it was first part on line 4. Now it's on line 3. So it must be moved, of course. The next one is the name. And because of that name inside and the same data type, he say, okay, it could be last name. And it is renamed. And it happens the same on the email address, support node, and so on. And for example, also the age is moved. And this is one which is totally new. And this is how it basically works. This is what it looks like when you start the MicroStream application. So on initialization of the storage itself, he shows you this dialog, and you will be able to accept what happened there. So it says, okay, let's say first name. This is the old one. So we have contact, first name, old class, and this is the new one. And it's the same names, the same position, and so on. That means 100% it's the same attribute. And then it becomes different. So it says, okay, it's the same data type. It contains something, contains a string name, and this is the new one. And 75%, it's just a renaming of the existing one, last name and name. And this is how it basically works. And then you will be able to say, okay, that's okay for me. That's exactly how it should work. And then you can accept it with yes. Legacy type mapping. That's most. It's at the moment it's quite hard to create a situation which cannot be handled automatically. To be honest, most of the time I try it, but you have to create a really weird situation that to not make it happen automatically. So okay, that's not really important. Let's move on a little bit. Best practice, I think that's important during the development. When we are able to delete the storage again and again, I would recommend to create some proper mockup classes to add data to the database for testing and stuff like that, and to delete the storage again and again. So it doesn't make sense to have legacy type mapping during the development. Changes multiple attributes in one class should be done step by step. That's also what I would recommend. Don't do updates, let's say 5 or 4 updates in a class at once. Just do it carefully, step by step, especially when you use in production storages. Could make sense to do it step by step, and you have always do a backup first, of course. That's also important. Creating backups, I already said that, mentioned that. Yeah, and sometimes data type changes require a special migration logic. In most cases, can't be done automatically. In this particular case, create a new attribute, start the application, transfer the data from old to new, and then shut down application and remove the old one. That works really great in our projects. And yeah, to be honest, as far as the application is in production, the changes in the database are not that much, I would say. Yeah, you most of the time you add data for sure, but changing the data is I would say it's a rare situation. Okay, that's it for now. Let's jump into the application to just have a short look how it basically works. Let me just clean up that a little bit. Backup strategies. I don't need this anymore. Legacy type mapping. Where is it? Ooh. Yeah. Okay. So team switch to master. Okay. So let's have a look to that. There is no data source. So there is one domain, I guess. This is the author object. So we have mail, first name, last name, a really straightforward entity. There is one controller just to create one. And that's it. So let me just start this application. First, I want to update, maybe an update. So during the start, I can answer the question. There's I've seen there is one. One is from Frank. We could use an AI. Yeah, that makes sense. That's a good point. I would say that's a special point for the GitHub discussions. Maybe that could help. And there is another one, Helio, do you have the customer that are using MicroStream and also using a regular DB like queuing sense for statistics? That means doing an overnight transfer on regular basis. So I think I would answer the first question. Do we have customers that are using MicroStream? Yes, we have. There are huge companies that are already using MicroStream. For example, the Allianz insurance company uses MicroStream a lot instead of MongoDB. They used MongoDB before, but because of the eventual consistency of MongoDB, they switched to MicroStream. And I would say to be honest, there are 4, 5, or 6 applications that runs on MicroStream, and there were basically normal application that runs through 30 countries around the world, and with around 400 concurrent users at the moment. So the Allianz is one customer. Then next customer would be the German airport, Frankfurt. They used MicroStream within their baggage concealing system instead of an Oracle database. So they moved to microservices and they migrate the whole Oracle database to a microservice architecture with a lot of different smaller MicroStream microservices, I would say, as a data provider. And many more, and many smaller projects. Yeah, but these are the biggest one I'm allowed to talk about. Okay, so, but the next, I didn't understand the DB like QLick. I never see that before. Maybe we have to talk about that a little bit later or via email or something like that. Maybe that helps. Okay. But yes, there is another point. So when we create a data provider, like we do in the training, I think most of the statistic tools are able to read from REST services. I think that's really straightforward. So, okay, let's move on in that application, which is still up and running, and let's create one. Just a single entry. Author controller. I just have to call it via browser. So let's say author and then create. Let me just double check. I think port, that's okay. Create authors, okay. No. Where is it? Authors. Here we are. Okay, let's get a list of the authors. Okay, there is only one author I created. And you see male, first name, last name. And now let's keep that storage. So I just stop the application. You see the storage is there. And let's move directly to the next branch. So let's double check the author entity. We have male, first name, last name. So let's move to the next team, switch to changes stage 1. And now you see the changes. We have one renaming male author and last name changes to name. So that is what basically happened. And let's start this and see what happened when we start the application itself. Okay, so let's initialize the storage. Here we are. So now this is the point where we see the changes and the guesses from, or the AI, I would say, who analyzes the changes and the entities and see, okay, male is changed to male author. First name is first name. It's the same. It's 100%. And when we have 75%, last name is changed to name. This is okay. I would say yes to do that. And that's it. So now let's have a look to the result. And you see, this is the result we get back from the entity. You see, this is really straightforward. And I would say in 99% of all refactoring, you would use this system. There is another one. I just want to mention this. There is another one, which is for those of you who say, okay, I don't want that automatic things. I want to control it by myself. What exact element should migrate to a specific one? And let me just open the legacy type mapping within the documentation. And there is one. So we all the time talked about the automatic mapping. This is done. We knew how it works. But there is an explicit mapping. It's also a huge topic within MicroStream. And there is the possibility to add a class, a specific class for that, which could look like this. It could be a CSV file. It could also be an XML file. It's a little bit up to you. And you see, you will be able to create an explicit mapping. So you could say, okay, this is the entity's old contact, which is moved to new contact, or the first name of old contact is moved to new contact entity first name. That means in that specific case, the whole name of the object has changed. So this is what happened here, basically. And that gives you the possibility to do an explicit mapping. But to be honest, I never use this. So I always use the automatic mapping. That works totally fine for me. No problems with that. But it's possible. So just let you know that this is possible and you can use it. And there is one example of that within the project. So when I stop it and when I move to the next legacy type mapping branch, team switch to changes stage 2, you will see there is some refactoring CSV within that project, and you see there is one mapping here, and this is how it basically works. So this is the old one, that's the current one, and that's the syntax, how it works basically. So, but you will find everything within the documentation. This is really big. So let's close this. Okay. some questions. Let me just check if I forget something. No, okay, that's okay. Okay, there's one question. What about multiple old mappings version migration? Hopefully I understand it right. But when you change one object multiple times, you always have to keep the old mappings. That means, let's say you change from version. Let's say we have an original version, then we have version 1, then we migrate, let's say 50% of all data to version 1, because the other 50% stays untouched forever in the storage. That could be the case. Then there is a second change from version 1 to version 2, and let's say these changes are interesting for only 30% of the 50% which are part of version 1, you know. And I think this is how it works. So you have to keep all the mappings for all version changes all the time, as long as there are some elements still on that version within the storage. So there is a way to ensure that everything is migrated at once. There is a possibility to do that. And then you can skip all your mappings. You will not need the mappings anymore. But then you have to, let's say you have to download the storage from the production system, for example, and then you have to do the migration of the whole graph let's say, or of the whole entities at once. Then you can skip, or you can delete all your entries, and that's it. Does it answer the question? But this is the way how multiple versions are handled within MicroStream, within the storage. Okay, so last but not least, and this is the last topic for today. This is the topic I skipped at the beginning. Oh, what is a liquid-based style?
So maybe I talk to you directly.
Yeah, of course.
For example, I have in Spring Boot projects, there you can default activate liquid-based. This is the database migration versioning tool.
Okay.
So let's say I have a version of my project, version 1.5 at one place installed and 1.8 at another place. And I have a path where I can migrate from 1.5 to 6 to 7 to 8, no matter which version my older, or no matter what older versions are my running in production projects are. Yeah,
got it. The question is if it's still required to have that this way, because the changes are part of your code itself. So it is handled in a way via GitHub, for example. So the different version and the different production versions brings its own database structure. Maybe that helps a little bit, but yeah.
I think that's an idea. Yeah, you mean I deploy version after version to migrate to this. Yeah,
that's all. Yeah.
That's
I think in that specific case, it's not needed anymore. So now I know what liquid-based means. Yeah, but I think that's not needed anymore.
Thanks.
You're welcome. Okay, great. So as I said, last but not least, just I want to share with you the last project. This is the one I skipped, and just to be fully consistent, I would say. Where is it? Here. Moment, please. I always have to find it. That's not easy at all. Configurations. Okay, here we are. So this is for you. Another URL. And yeah, the reason why I skipped it at the beginning is because during the last few projects we have seen, we already have seen all the different types of instantiations of MicroStream. So, and therefore it's a really basic topic. And I just want to share you the different possibilities. And there is one part. So let's have a look to the DB class in that case. And the first thing that could be interesting for you, some of you ask, is it possible to have multiple embedded storage manager? And yes, it is. So you could have as much storage as you want. So it's totally up to you. And in that case, I have four different and 4 different root objects. I have no idea if it makes sense to have that, but but it's basically possible. And I did that because to show you the different way to instantiate the storage manager. And the first one is the easiest one. We already talked about that. That is the fastest one. Just to create a storage manager, you have to add the root object, you have to add the path, and that's it. So easy, initial short storage, I would say. The second one, this is one we have seen in the last example. That this is the one we use the MicroStream XML file. And there are many different properties. You will find all the properties within the documentation. And this is working okay, I would say. Not my preferred way to initialize, because sometimes I want to have the environment variables, for example, as instantiation, or especially with Micronaut, I want to use the YAML file. Then it makes sense to have this in another way. And that brings me to the third way. This is what we use. This is the builder pattern mode. I would say you can configure mostly everything in that builder pattern. There are some stuff which is not possible to configure, especially what I've shown you, the way to store the data on the hard disk and writing the mirror to the AWS S3 bucket. This has to be done in a different way, but I think that's the most recommended way to initialize, especially at the beginning. And last but not least, this is the way to create a foundation. And based on that foundation, you will be able to create the storage manager. But the point is in that you always have to create, and these are the 3 steps. You create a configuration, and based on that configuration, you have to create a foundation. And based on that foundation, you create the embedded storage manager. And this is basically how it works. And as you can see here, there are some configurations could be done on different layers. So you can see on the configuration layer, you can set the storage directory, the backup directory, the channel count, and so on. But some other configuration has to be done on the foundation itself. And this is sometimes a little bit confusing, but I think it's important to know that we need these 3 objects. We need the configuration, a foundation, and then out of that, we can create a storage manager. And this is the same what we have here. So we have the file system. This is just the file system itself. So to store it, then we created a configuration. And based on that configuration, we create a foundation. Where is it? Just have to... Oh, where's my foundation? Not in here. Maybe it's internally built, but that's okay, I think. There are some examples also based on that, and also in my GitHub account. And yeah, I want to share this with you, the different types of initialization. And that brings me, I would say that brings me to the end, I would say. Let's jump back to the first slides to just double check if we have all the topics for today. Here we are. We did the warm-up. We talked about advanced configuration. We forgot the transaction stuff, but we got 20 minutes left. So if there are no more questions, we could quick jump in the eager and lazy storing. I think that's an interesting part for you. But there is one question regarding the link of the form. I think Marcus said that we send it to everyone, right? So is Marcus still there? Just a second. So during the time, I will open the example to you. I think it's enough to just have a short look within the project itself. So give me just a second to open it. Close. Find the right branch. That should be. Yeah, I think that's really useful to know that. Okay, so this is exactly what we need, but let me just check if we are on the right branch. So yeah, this one is the right one. Okay, so let's just have a look to some lines of code. Yeah, at the beginning of the training, I explained to you that most of the time we use a store method, which is called internally, or this is the default behavior, which is called lazy storing. And lazy storing means that when you, for example, if you have a customer and the customer contains orders and orders contains order positions and stuff like that, and you call the method db.storagemanager.store and you hand over the customer itself, this means that only the customer itself will be stored. No matter if you changed something within the orders or you changed something within the order positions, that doesn't matter. Only the customer will be stored. And this is exactly how the lazy storer works. The lazy storer stores only the object which is handovered and only this object, not the entities below. And this is the point where the next storer comes into play. And you see, there is one possibility to use it in a different way. So there is a possibility to say db.storagemanager.create lazy storer. And this lazy storer can be used in a way for, yeah, kind of like a transaction. We already talked about this, for example, I can say ls.store b, and I think the naming of that method is not the best, I would say, in my opinion. I would call it ls.register, kind of like that, because the store method is only to register that exactly object B for storing later on. That means at the end, when you call the commit, all the objects will be stored to the storage itself. And this is how the transaction basically works. And this could be part of a try catch. And at the end, you will be able to use the reloader to make a rollback in the end. So, okay, this is how it basically works. There is another possibility to create an eager storer. And this eager storer works different to the lazy one. This is an eager storer. And yeah, guess what? It is the same like the lazy storer, but different, I would say. It stores everything below the object itself. So that means when you change the customer and you change something in the orders and you change something in the order positions, everything is stored from the customer beginning. So every sub object will be stored also. This is how the eager storer works. But you have to be careful. Just imagine you have a huge tree or a huge graph, and when you use the eager storer on an upper element, it could be the case that the whole graph below will be attached. You know, I explained that will be appended to the binary file, and that could lead to a huge amount of data for a short time on your hard disk. So not the biggest problem, but you should use the eager storer quite carefully. It could lead to a huge impact on performance. But sometimes it makes sense to have that, and you can use it also use it in a transactional way, I would say. like this. Okay, I think that's really straightforward to understand. And last but not least, let's talk about the reloader. So what happened when something goes wrong exactly here? So let's say, let's say we collect, we do the for each for the first 2 elements, and something went wrong after 10 elements. So what should we do? So, and this is quite dangerous, because if something goes wrong, then the first 10 elements are changed for everyone, because you have to consider that within MicroStream, every concurrent user is working on the same tree. So these are no working copies. So, and that's why that's a big advantage on the one hand, but on the other hand, it could lead to problems, especially in this case, because everything which is changed here is at the same time visible for everyone, and that's exactly the point where the reloader is that important. You have to reload or to unchange or to revert those changes in case of an exception. In that case, okay. But there is another thing about concurrency and how to handle concurrency, but this is part of the advanced 2 training next week, and also quite interesting to visit. So now I'm finally done. So I would say just a small topic: lazy store, eager store, how to reload. You can find the project within my GitHub account. Okay, so let me just double check. Now we get everything. We answered most of the question. Let me just double check your questions. There is one question: how to manage replication. This is a part which is important for the cluster. MicroStream provides, instead of an embedded storage manager, there is an cluster storage manager, and at the moment we provide this cluster manager within our own cluster software as a service solution on our platform. But this is also possible to install it, I would say, on your on-premise devices. And for now, you have to contact us to make some guesses about what is the size of your project and licenses and so on. But this is done by a specific cluster storage manager. But it's possible, basically. I hope this answers the question. I think that's a huge topic to answer this, because replication is such a complicated topic. It is what I can say. It's eventual consistent. It's a one master replication. I think that's a lot of topics about replication and cluster and stuff like that. Huge topic, but I hope I could answer this in short words. Have to leave. Very interesting. Thank you. That's okay. Replication. Use MicroStream for any brand means it does not matter if you are dealing with large or small amount of data. I think MicroStream could work for every project. It depends on you, and it depends on how is your integration. I think it's different. It's a kind of like a mind change of handling data. I always said, why to send data to a different server just to store it to the hard disk? Why not to store the data directly on my machine to hard disk? It's quite the same. Why to send the data through the whole world to store it? It makes no sense. But yeah, this is a topic we can discuss forever, I would say. But yeah, to be honest, I could imagine to use MicroStream for any project on the market. Maybe not as a single solution, but maybe as a solution for just one part of the project. So it makes sense to have not all of your data is needed in high speed. So use it just for a small amount of data, for the most important ones of data, which has to be provided in high frequent and high performant way. And just put the archive data to a slow storage, yeah, which is a cheap one maybe. Totally up to you. I think it's not a solution for everything, but for the most of the thing. And you have to find the right situation for MicroStream. Microservices, mock-up data. There are thousands of different use cases for MicroStream. Thank you for the session. Replication, we already talked about that. There is one, can MicroStream handle join GTA context for XA transaction? Holy moly, this is this is hard for me to answer. I don't really don't really know what it means exactly. Maybe this is a question for an email. Just send me a mail or add it to the GitHub discussions. That could make sense, because I have to Google some stuff for that. Okay, thank you. One more session. Can you please share the link form? So you will get the certificate, all of you, all participants. So I think it's not needed to fill the form. I guess Marcus said this. Is it possible to stream data from the disk? For example, if I have a 1 GB binary file stored, is it possible to stream it without loading the whole file into the RAM? Binary file stored, is it possible? I guess not, or I'm not sure. I hope I get it right. There is 1 GB of data on the disk, right? And you use MicroStream for that. You mean you want to stream on disk, right? You want to search data on disk. Is that what you want to do? But yeah, to answer that is no, you can't do that. So you have to load the data to stream through it. And I think it's the same on any other database on the market. So when we talk about a PostgreSQL database, they have to load the data from the disk to search in it. I think it's not possible to search directly on disk. I'm not sure if there is a technology on the market that is able to just search without loading. So I think that's not possible. So, and therefore it's always needed to have. This is also always a great question. Is it expensive to have a MicroStream with, example, 1 TB of data? I think that makes no differences. In the past, you have an application server which needs 4 GB of data RAM. Then you have a cache in between the database and the application server. It needs 4 or 8 GB of data, and you have a database itself. Let's say a PostgreSQL database, which has, and this is a good question, how much RAM do we need on the database side to have a database with 1 TB of data in it? What do you think? What would be a good RAM consumption for a PostgreSQL database? And this is exactly the point. When you put all these 3 technologies together and use MicroStream instead of that, I'm pretty sure you would have the same amount of RAM on 1 machine. And I think this is much more easier to handle and much cheaper than a database with a lot of amount of RAM. Okay, but I hope that answered that a little bit. Okay, so we are in time, 4 minutes left. So if you have some further question, no problem. I will stay for around 20 minutes more, so I will answer that. But in total, I would say that's all from my side for the advanced training part 1. Hopefully, I see you next week for the advanced training part 2. Then we talk about concurrency and stuff like that. We will have a short look to the cluster itself and so on. I'm pretty sure that's also quite interesting for you. Thank you for being with me in that training. I hope it was interesting for you. Try it out and enjoy MicroStream and EclipseStore. Let me know if you're in trouble with something. Write me an email, send me an email, use GitHub discussions, try it out. And that's it. Thank you very much for joining. And yeah, have a nice evening and a nice week. Thank you. Hi.
Yeah, Arno here. So first of all, thank you very much for the two sessions that I had a chance to attend to. The product is very, very promising because I remember all the the tough work that we usually do in order to to reach the same goal as the one targeted by MicroStream. I believe that it will be, widely adopted because it's just taking away a lot of stuff like, you are a basic Java guy, you know how to design a solution based on client requirement, and then you have to handle all the complicated layers. You need to learn how to deal with Hibernate.
Yes, of course.
Which doesn't at all add value. So I think it's a very, very good thing that you are putting this in the market and shout. Yes, please shout louder. So things are really when you want to push something in a good direction. So luckily we living in a world where when there is a noise, people look at what is going on, and then some people understand the core idea of what is going on. So very, very, very good. So
thank you.
I'm wondering if you could, for the session of Thursday, address again all the transaction aspect and rollback that is provided. Is this something that you can consider?
Yes, of course. So if you want, I can try to put it again to the Advanced 2 training. I think we have enough time to do that in a more advanced way. We can go through the project again. So yeah, to be honest, it wasn't enough time to share that. Yeah, that's okay. So we could do this in the Advanced 2 session again. Yeah.
Okay. And I was wondering if, because finally I understood that the idea really, to benefit from this tool is to think differently when you design entities of your entire solution.
Yeah, so it makes sense to do that. Yeah.
I guess you have, with your experience for the moment, you've come up with maybe good approaches or kind of framework of thinking, conceptually speaking.
Yeah. I think so. So the easiest way to use MicroStream is just to copy the same data model which is already in place with an Hibernate solution. That could be work. That could work, of course. It's not the most efficient way to handle data, but it will work definitely. So so that's also a point. Many people ask me that how to migrate from a already existing Hibernate application to MicroStream. And in some parts, or sometimes it's quite easy just to use one or two specific entities and grab it and yeah, like let's say store it with MicroStream and not with Hibernate, but keep the structure as it is and just use the entities as they are with all the Hibernate annotations and so on. It doesn't matter. It will also work within MicroStream. And yeah, you know what I want to say? Just keep it simple. The data structure itself will not be the best, of course, because there are always ways to make it better and to improve it and stuff like that. And to be honest, I would not create a data model which looks like a Hibernate data model at the end within MicroStream. But it will work basically. That is not just to keep it easy to migrate, I would say. That will work. I think the only thing which you should consider is the lazy data stuff, because that could be quite challenging to use it within the lazy stuff. As I shown you, that could be a little bit different, but the normal structure, I would say it will work. There is no that much difference to the data model with MicroStream and with Hibernate. It's in a way it's the same.
Okay. I really like the where you talk about considering the scenarios of the use cases that the end users of our solution could handle every day. From there, and put in front what is the appropriate strategy to use the lazy loading, lazy references. I think it's it adds a lot of values.
So I think the point is, I think the point you have to understand is that this is a real problem at the moment on the market. Everyone puts all the data to one single source of truth, I would say. There is one single source database, and there are terabytes of data in it, and most of the data are there, and no one needs it. So it is old data from years before, and it's not really important for the production system, I would say. And I think that's a big point. And most of the time it is the case when you remove the outdated data, which is not needed all the time. Then you have I would say the 10% of the most important data. And especially for this data, you will not need lazy loading anymore, because the data is needed all the time. And the more concurrent user you have, the more the data stays inside the memory. It's the same on your application side. The more concurrent user, the more data is on the application server, because it has to be cached and so on. And the more efficient your data model is, and the less lazy loading you will need, because you have the data and it should be in memory, and it's important to have it because it's the data for high speed, I would say. And the other data is data for some don't know where to store it, and it's an archive, I would say. So and I think that's the point. Lazy loading, it's okay to use it, and sometimes it's important, but in our experience, the better your data model is, the less lazy loading you will need, because you just carry the data, which is really important.
It's clearly a shift conceptually speaking.
It is definitely, it is. And also the idea, as I said, people always talking about scaling, and we need more data and more data. And sometimes, to be honest, there are companies, they need that much data. Let's talk about Google and Facebook and stuff like that. But most of the companies on the market use only 20%, I would say, or 30% of their real data of the database. And it makes sense to think different, to separate data from each other, to decide which is the really most data, and to find ways to archive data in an automatic way. That means, as I explained, after 2 years, or data will be archived every night. Some more data will be moved from the production storage to the archive storage, for example. And then scaling is not a topic anymore. So when you do it in that way, because data aren't scaling, they stay always the same size, and the performance stays always the same. But it's mind changing, I would say. So
I think it would be good if you plan something related to solution design. Just considering EclipseStore like a tool, not the core of that training, but how you could. I will take the example of the fund industry, because I'm living in Luxembourg, so this is our industry here.
Okay.
There are a lot of use cases where data are needed, where some reports have to be accessed on demand in real time.
Okay.
But but liaising on based on very deep
got it. Yeah. So, have you ever heard of what is the name? GraphQL?
Yeah.
And maybe that enables you to create REST endpoints where you can decide in a dynamic way what kind of data you want to have. I think that could be a thing. That means you create one endpoint, and that gets a specific GraphQL statement, and it queries the data automatically based on. This is kind of like an SQL language for graphs, and I think that could solve your problem in a way. If I understand, if I understand it right.
I need to have a look at how to bootstrap with that, and if I would have been in the position of choosing something to pitch to a team or something like this, definitely I will go for EclipseStore. Because you stick on your development. I mean the in Java, you think everything in Java, and then you don't bother yourself with other layers of technologies, because you asked the very right question. So a database system will store the data in the file system at the end. So on top of that, you have the layer which handles session pool, users, and all this stuff.
That's right. Yeah.
And sometimes you can also have the same level of segregation and security
Of course.
in your own application. So why
that's right
having at two places, and then try to have within the team someone who's a DBA, but who cannot help a lot on when it comes to designing a solution in Java. So we need to take those questions really seriously and see.
That's right. That's people always ask, are there any weaknesses on MicroStream? And I would say this is really one. We don't need any database administrators anymore. So because all is Java, and this is made by the Java developers. So there are no more DBAs anymore. So maybe that's different. Yeah.
No.
That's right.
So very very interesting topic. Thank you very much for the time, for the effort, and for the initiative.
You're welcome. Yeah, great. Thank you.
Yeah. So see you then next week.
See you then. And if you want to have an individual session for your team, for example, let me know. That's no problem. We can do this within an hour to make a short introduction to MicroStream. Maybe that's interesting for you. So if you're interested,
This is why I am attending to the session to see what it is about, and then I really see an interest in that. So by the way, what is your email address? Because I don't have it.
One moment. Let me just type it. Went to all. So here is it.
Okay, great. So thank you very much, Christian. And
you're welcome.
Bye, everyone.
Bye. See you next week.
Bye.
Bye.
Christian?
Yeah.
I have a technical question. I attended the fundamentals training in October.
Okay.
And I tried to get the certificate before this event.
Okay.
And didn't get an email till now.
Oh, okay.
And
let me check. Did you fill the form?
I did fill the form, and I also tried 2 different emails.
Oh, okay. I have to double check this. So let me just take a note for that. I disable the the screen sharing for the moment, but just take a note. So the name was David Koenig, right? So
right. So maybe you find multiple entries because I tried.
So anyway,
Yeah.
anyway, you will get a certificate. Have you taken part on the fundamentals a few weeks ago or 2?
Yes, in October, mid-October it was, I think.
Ah, okay, okay, great. So
yeah,
I could imagine. So
Christian,
and maybe
sorry
I
for
didn't.
interrupting. So we will check this and we'll send definitely certifications to all participants who visited trainings this year.
okay,
So we had
great.
some changes in our organization and currently too much issues. So sorry for that.
Okay.
We'll take this, send you the certifications.
No problem.
So,
Thank you.
I took the note anyway, so so we will not forget that.
Okay. Then thank you very much for this very interesting session. Was as good as the fundamentals. So looking forward to next week.
Okay, see you then.
Bye.
Bye-bye.
I have one question too.
Yeah, okay.
I have a scenario in mind which I couldn't quite understand with the concept. It's in a load balancing scenario where I have multiple pods running. So the request gets sometimes to pod 1 and sometimes to pod 2. If I get the data always in memory, my my data will differ. So if I add add request which runs in pod 1, how will pod 2 get in sync with that? Is this a cluster solution?
Yeah, it is. Yes, we use especially for our cluster solution, we use Apache Kafka in the backend, and the Kafka replicates data to all the different nodes within the cluster. So as I said, there is a one master replication, so that means there is one node which receives all the write requests, and from that node, all the data will be replicated to all the other nodes. And this is why this is also the reason why we have an eventual consistency, because you could call the load balancer and it leads you to the node 4, for example, and the node 4 doesn't have the latest data, I would say, and therefore it's an eventual consistency, I would say, but it's a master replication, and that's how it basically works. Yes.
Okay, so I will have always to go to the cluster solution if I run in Kubernetes or something.
Yes, and you can get this as you can get this within our cluster, which is explained next week. And then I also want to talk about a little bit about the cluster and the cluster solution, and you will be able to get this cluster as an on-premise solution, but this is kind of like a service that we do for the moment. There is no product we can deliver and say, okay, install it and that runs forever. So we have to do this in a kind of like a service way, so that we introduce you how to install it, because you need a Kubernetes cluster, you need all the different configurations for that, because this is not really an easy task. So and therefore it's possible to deliver that as an on-premise solution, but for the moment I think it's easier to use the cluster solution as a service from our side.
Okay, thank you.
You're welcome.